Okay, we just presented the lecture to you. We're in section 38, and we're going to start doing the examples now. There's not many examples over here. 1, 2, 3, and 4. We'll go through these. All right. I do want to point out when you're looking at the notes, you should see that they're referencing figures that you need to look at. I'm not going to say they're the best figures in the world. These are figures that typically I lift from textbooks somewhere, textbooks that we typically use at Essex County College. The reason I do that, I have a tough time drawing myself. All right. But again, they're books that we do use at Essex County College. So let's take a look, and I'm going to do another share with you. Give me 1 second to do so. All right. So, when I do this over here, I'm going to point out, I'm certainly going to do number 1 for you. And, number 1, it refers to a figure, and that's the figure 185 on page 519. So I'll go to that picture over there, and, certainly, I'm going to point out that reading that they want the volume of that wedge over there. And as I'm doing this over here, the first thing I understand is that they're kind of leading me to what the answers are. So I'm going to put down, I'm seeing this object over here, which to me is a rectangle, but I'm going to turn it into a volume by making a little box out of it, something like this over here. So what I have to do now is I've got to get the volume of that box. I got to get the volume of that box. So I'm going to say, I sort of see this thing going along the x-axis. So I want to draw a picture of what I'm seeing over here. And this looks like 2, this looks like 3. And the equation of this line over here is y equals, that's a line right, by the way. Its slope is going to be minus 2/3. And the y-intercept is 2. All right. So I'm going to, look at the box, and I notice the box looks like this, and it's coming straight out at me. Something like this over here. So I'm going to say the differential is dx over here for that box. I'm going to be adding the boxes together. I'm going to start at 0. I'm going to stop at 3. And this is forcing me now to get the dimension of the box. What's this dimension over here in the box? Well, looking at the picture, it's 2.5. 2.5 for me is 5/2. Now, what's the height of the box? The height of the box is actually this curve over here. What's that? It's this thing. Let me write this down a little differently. I'm going to write down 2 minus 2/3 of an x. This is the first milestone in the problem. That is the volume integral. We got that. This is the volume integral. What am I going to do now? I'm going to simplify the integrand. 0 to 3. That's going to be 5 minus 5/3 x dx. I'm doing the integrations now. What do you get over here? 5x minus, that would be 5x squared over 6, limit integration 0 to 3. What does that give me? 15 minus 5 times 9, which is 45. 6, we'll do that later. Minus, well, the lower limit's nice because both of those terms would be 0, and 0 minus 0 is 0. Let's put this down, 15 minus, I'm going to reduce that. I'm going to say 15, we're dividing by 3 over 2, and 15 minus 15/2 is 15/2. All right, let me go to the key. And I noticed I did this over here. And did I get the correct integrand? Yeah, let's take a look at it. And I did right over here. Okay, let's do the next one. Next one, the picture's right there, so I have to go to another page. So I'm looking at this over here. And again, I don't think it's the best picture in the world. It's something I look at these things and I wonder, do I have the picture right? And it's a terrible picture, by the way. But let me flatten it out for you. And I'm seeing something like this over here, where this is 3 and that's number 1 over there. So what's the equation of this line over here? It's y equals 1/3 of an x. The y-intercept is 0. And what do? They have these little tiny regions over here that they kind of rotate like this, and they make a half of a disk out of it. So I'm going to say, I think I know it's a differential dx. I'm going along the x-axis. I'm starting at 0, going to 3, dx. And now I got to get the volume of this thing over here. And what's that? It's half of a disk. So it's going to be 1/2 pi r squared. What's the radius over here? It's this, which is just 1/3 x. Let's see if we can do it. And again, this is a milestone. If we get this, we have the volume. we want to just see if we can do the integration now. So let's put this down. I'm going to put the number down. It's going to be, let's see, pi over 18. We have an answer key, and I want to encourage you, use the answer key. 0 to 3, x squared dx. Well, it's going to be pi over 18. It's going to be x cubed over 3, 0 to 3. All right, let's keep going. That's going to be pi over 54. 3 times 18 is 54. X cubed is 27. Minus 0 cubed is 0. And what do you get? 27 over 54. Well, 27 goes into 54 twice, so pi over 2. Let me put out the two milestones are the integration. Did I get that? Yeah, it's right here. And did I get the correct answer? Yep, right there. The next question. And this one says, assuming that a given graph, I'm seeing it, seeing the picture, it's figure 187. It's composed of circular regions of equal radii. Find the area under the curve and then the values of C. And this has something to do with the average value of a function. So I'm going to blow it up and I see the numbers and I'm going to, talk about, me looking at a picture, and I'm going to do this, which is a 1 by 1 square here and a 1 by 1 square there. The areas of those things, really simple. These two guys are just one unit, 1 square unit each. All right. Now, what do I notice about this over here? I want to point out, if you took this thing and folded into this and took this thing and folded into this, it would fill it up. And what would you be left off with? You'd be left off with an object that looks like this over here. So if you folded those two regions down, you'd be left with a 4. That's 4 units long here. And this was 1 unit long here. And what's the area of that? Well, the total area would be 4. All right. So I'm going to say they're talking about this over here now, if I did that. Then they're saying along the path between -2 and 2, is there a number along the path where the function would evaluate to the height of that? And it does, right here and right here. They're the two places where that evaluated to 1. And what is it going to be? At this number and at that number. So what's the C? The C is plus or minus 1. So this is the area. And this has to do with the attribute of a function. Let's take a look at the bottom. They give me that. They may have done it differently, but they give me the areas for, and they give me the C as plus or minus 1. All right, let's go to the next question. And that's number 4. They want to calculate the average value. And this is the formula that we've done. Someone says, why did you do it over there? It would have been too tough for me to come up with the function for that. So it'd be a lot of work. So I didn't want to do that. So this one doesn't seem like much work, but the average value, I'll call it FAV, AV. I'll put it AVE equals 1 over upper 9 minus lower minus 1 integration -1 to 9 e to the minus 3x dx. Well, I gotta see if I can do that. I got a key though. 110. Yeah, my 9 minus 1 is 9 plus 1. Oh boy, I gotta do that integration. So it's gonna be e to the minus 3x over minus 3. Again, if you're having trouble with this, please, I think you need to go back and review integration, a simple integration. And if you're still having substantial trouble, see me during office hours and I'll go through every step that's required to come up with that, including if you need to use U substitution. What's limited integration over here? -1 to 9. And I got to do that. Right, I want to get full credit. So I'm seeing -1/30 e to the minus 27. And it's going to be minus e to the 3. If this is your answer, you'll get full credit. I want to simplify it though. And let's do that a little step at a time. A common denominator, 27. That'll be 1 minus e to the 30th, right? 27 plus 3 is 30. This is going to be 30 e to the 27. And then what are you going to get? E to the 30th minus 1. Let's look at our key. Mistakes happen. And I want to see if I got the integral. I did. I got that. And did I get the answer? Either 30th minus 1? Yep. By the way, they do approximate it. You don't have to approximate the number unless you want to. Okay, thank you. Again, if you need any assistance, please come by during office hours. But I can't say this enough times to you. A lot of students think they don't need to do that. You need to do homework. You need to spend a considerable amount of time reviewing what we're doing in class and then seeing if you understand it by seeing if you can do homework. We give you a set of homework problems to try on your own, independently of me or anyone else. If you do need assistance, please come by during office hours and I'll be more than happy to help you.